Hi, everyone. I wanted to give you a little bit of a snapshot of probability to help you with today's assignment. So, even though maybe it goes without saying, I didn't want to assume anything in that I always want you to think for probability that it's the ratio of number of favorable outcomes of an event to happen and the total number of possible outcomes. So, think about that in terms of what we did with rolling the dice. If I were to ask you the probability of rolling specifically double sixes, and I want you to see how to write that in mathematical form, you would say the probability of double sixes, or literally you can just write P for probability and then in parentheses talk about the favorable outcome, meaning we're looking to see how many outcomes there are of double sixes out of the total number of outcomes. And visually, even though I'm blocking one of the dice being 5 and 6, I know you know it's there. Visually, we can look at it that way, that double sixes is this box and it's 1 out of 36 possible outcomes. So what I want you to think about, because you're going to be doing probability of compound events, is dependent or independent events. This is an example of independent events because if you rolled a 6 here, it didn't really affect the outcome of the second dice, of the second die. You can roll a 6 on one and a 6 on another. If you were picking numbers 1 through 6 out of a bag, and you pick 6 first, and you didn't put that number back in, that's probability of dependent events because you would only have 5 numbers in the bag. But let's stick with dice for a second because you could have probability of compound events, this being 2 different events, but let's say we could have a probability of 4 different events or 2 different dice rolls. What do you think, and then pause, what do you think the probability would be for rolling double sixes 2 times in a row? You're pausing so I can keep going. Well, I would take a look at a visual model and say, like, ooh, if we roll double sixes, then within that 1 out of 36, rolling double sixes again, well, that's probability of compound events kind of times 2. Is that you would write it as probability of double sixes followed by double sixes. And then, really, with probability, when in doubt, you're kind of multiplying. 1/36th of 1/36 or 1 over 1,296 is our probability of rolling double sixes 2 times in a row. I'll let you think of if you want this to affect your dice golf game, because maybe you're going to want one of your holes to be rolling double sixes 2 times in a row. I mean, you might be rolling for the whole summer before you get 2 sixes in a row, but maybe not. I don't know. You would see. Let us see if I take you through kind of what I like to think of as vocabulary for this is independent events is occurrence of one does not influence the other, and dependent is occurrence of one does affect the other. So if we looked at kind of similar things as far as the probability of picking a 4-digit code at random, where you can repeat digits. So that's independent events because even if my first number is 0, and you can have 0 for this scenario, you can have the second digit being 0. So it's 10 times 10 times 10 times 10. Or if I was to say in probability terminology, what's the probability of selecting 7,234? It would be 1 in 10,000. Same thing with the probability of selecting 7762. In these scenarios, it's 1 out of 10,000. Every single 4-digit number has an equal chance, a 1 out of 10,000 chance of being your number. Dependent events in this scenario is different because we would give the rule saying that you can't have repeat digits. So we can think of that as 10 times 9 times 8 times 7 because you can't have repeat numbers, repeat digits. So I want to ask you, what's the probability of selecting 7,234? Well, it is 1 out of 5,040. But now my question to you is, what's the probability of selecting 7,762 in this scenario? Again, I'm going to pause, or you should pause. Well, you might say 1 out of 5,040, but you'd be wrong because, oh, I'm wrong. Ooh, I'm wrong on the screen. I didn't change it. I'm going to change it right now. 1 out of 5,040 is wrong, and 1 out of 10,000 is wrong. The probability in this scenario of selecting 7,762 is 0. No probability because you cannot have repeat digits. In this scenario that we've created, you could not pick 7 more than once. So the probability of doing that would in fact be 0. Take a look at the assignment and the Math is Fun links. Explore. I don't want anyone spending more than 45 minutes. In fact, I probably don't even want you spending more than 30 minutes on this assignment. But I hope you enjoy exploring probability because it's a pretty fun field of mathematics that we don't really cover as much as we should. All right, see you tomorrow. Looking forward to our last class. So kind of looking forward to it, kind of bummed about it. See you soon, though.